A useful way to begin is to notice that summarization is not really about making text shorter. Making text shorter is part of the task, but it is not the full task. Suppose you have a long meeting transcript. It has greetings, repeated ideas, half-finished sentences, and a few important decisions. If you ask for a shorter version, you might get a paragraph that sounds neat, but still does not tell you what to do next. It may remove the most important owner, or it may keep a general discussion, but miss the actual decision. This happens in many everyday information tasks. A student has a long article and wants to know whether it is worth reading. A team lead has 6 pages of project notes and wants to know which decisions are blocked. A product manager has 50 customer comments and wants to know whether a feature request is isolated or repeated. In all 3 cases, the source is long. But the real problem is not just length. The real problem is attention. So the naive definition is summarization means compressing long text into short text. That definition is useful but incomplete. A better definition is summarization is goal-directed compression. We shorten the text in a way that preserves the information needed for a particular reader and a particular decision. The same source can support different summaries. A manager reading the meeting transcript may want decisions, owners, and deadlines. A researcher may want evidence, uncertainty, and references to the original claims. A customer support team may want the complaint, the product involved, and the proposed resolution. None of these summaries is automatically the best one. Each one is best for a different use. This is an important shift. If 2 summaries of the same document look different, that does not automatically mean one is wrong. They may be optimizing for different readers. The question is not, is this the one true summary? The better question is, does this summary preserve what this reader needs for this task at this risk level? This is why the practical word is goal. Before you ask a model to summarize, ask what the summary is for. Is it helping someone decide whether to read the full document? Is it helping someone act without reading everything? Is it helping compare several documents, or is it just giving a quick orientation? If the summary changes a decision, then importance is not an abstract property of a sentence. Importance depends on the reader's task. A caveat that looks small may be the most important part if the decision is risky. A detail that looks interesting may be irrelevant if the user only needs action items. One useful mental model is to treat a summary as an interface to a larger document. The reader sees the interface and decides act, read further, or ignore. If the interface hides the wrong thing, the reader can make a bad decision. If the interface is faithful and focused, it saves time without hiding the important structure. So before we ask for a summary, we define the purpose. We can say, summarize this for a product manager, preserve risks, keep it under 5 bullets, and include next actions. Or, summarize this paper for a student, include the research question, method, result, and limitation. These instructions are not decoration. They define the summary. You can try this immediately with one document you already have. First ask a model, summarize this. Then ask a second time with a reader, a decision, a length, and required fields. The difference is usually visible. The first answer may be fluent. The second answer is more likely to be useful. The practical rule is simple. Do not start with summarize this. Start with summarize this for this reader, for this decision, with these fields, and with this level of risk. That one change turns summarization from generic compression into a useful NLP workflow. The first family is extractive summarization. Extractive means that the summary is built by selecting pieces from the original text. The system may copy whole sentences, phrases, or passages directly into the shorter output. Imagine a document with 5 sentences. Sentence 1 introduces the topic. Sentence 2 gives the main problem. Sentence 3 gives evidence. Sentence 4 adds an important condition. Sentence 5 states a recommendation. An extractive method asks, which of these sentences should we keep? A simple system might score sentences. It could look at word frequency, sentence position, similarity to the document as a whole, or graph-based centrality. In a news article, Early sentences may be important. In a research abstract, a sentence with method and result terms may score highly. In a meeting transcript, repeated terms may reveal the main topic. This is not magic. It is a ranking problem. We split the text into candidate units, score those units, and select the top ones under a length budget. The selected text becomes the summary. This is also why extractive summarization is a useful teaching baseline. You can almost implement the idea with a few lines of pseudocode. Split the document into sentences. Score each sentence. Pick the top 3. Put them back in a readable order. That simple version will not be the best possible summarizer, but it makes the mechanics visible. The strength is traceability. If the summary sentence came from the source, it is easier to audit. You can point back and say, this exact sentence was in the document. That makes extraction useful when evidence matters, when legal or policy wording matters, or when the user wants to inspect the original phrasing. Traceability also changes how a user reads the summary. If the summary contains a sentence that sounds surprising, the user can jump back to the original passage and inspect the surrounding context. That is different from a generated sentence where the wording may be new and the evidence may not be obvious. But selection is not synthesis. Extractive summaries can feel fragmented. A selected sentence may depend on context from a sentence that was not selected. Pronouns may become unclear. The system may keep a detailed sentence but miss the bridge that explains why it matters. Sometimes the most important idea is spread across several sentences and no single sentence captures it well. Here is a small example. The source says, the rollout was successful in the pilot group. However, the result depends on manual review and automation is not ready for high-volume use. If an extractive system keeps only the first sentence, the summary sounds positive but misses the condition. The selected sentence is true, but the summary is misleading. This is a subtle but common point. A summary can be made of true sentences and still be misleading as a summary. The evaluation is not only whether each copied sentence is present in the source. The evaluation is whether the selected sentences preserve the source's important structure. This method is useful when you want a conservative first pass. If traceability matters more than elegance, extraction gives you a safer baseline. It also helps build hybrid systems, where you first select relevant passages and then ask a model to rewrite them more clearly. The practical rule is, extractive summarization preserves wording, but it does not guarantee completeness. It is safer in one way and limited in another. It can tell you what the source literally said, but it may not give the reader the coherent synthesis they need. So when you see an extractive summary, ask 2 questions. Can I trace each sentence back to the source? And did the extraction remove context that changes the meaning? Those 2 questions already make you a much better evaluator of summaries. In the next step, we keep the idea of evidence, but we allow the system to use new wording. That gives us more readable summaries and also a new class of risks. The second family is abstractive summarization. Abstractive means that the system generates new wording rather than only copying sentences from the source. This is closer to how a person often summarizes. You read several paragraphs, understand the main ideas, and then explain them in your own words. You may combine 3 points into one sentence. You may remove repetition. You may adapt the wording for a particular audience. This is why LLM summaries often feel fluent. A language model can take scattered ideas and turn them into a compact paragraph. If the source says that customers complained about setup time, unclear pricing, and slow support, an abstractive summary might say, customers like the product value, but onboarding and support issues are slowing adoption. That sentence may be easier to read than a list of copied complaints. The benefit is synthesis. Abstractive summarization can connect ideas that were separated in the source. It can use simpler wording. It can create a summary at the right level of detail for the reader. This is especially helpful for long transcripts, messy notes, and documents with repeated points. For example, imagine a product feedback file where one customer says setup took too long, another says the tutorial skipped a key step, And a third says, support solved the problem, but only after 2 emails. An extractive summary may copy 3 separate complaints. An abstractive summary can say, users are not blocked by the core product, but onboarding support is creating friction. That is a useful synthesis if the source really supports it. But fluency is not proof. A sentence can sound polished and still be wrong. The dangerous error is unsupported detail. The model may add a cause that was not stated, make a weak claim sound certain, or turn a possibility into a fact. For example, the source may say, several users reported delays after the update. A bad abstractive summary might say, the update caused system-wide performance issues. That sounds plausible, but it is stronger than the source. The original text says several users reported delays. It does not prove system-wide performance issues, and it does not necessarily prove causality. Notice the direction of the error. The model has not invented a completely unrelated topic. It has made a nearby inference too confidently. This is why summarization errors can be hard to spot. The wrong sentence often feels close to the truth. A better habit is to ground each claim. For important summaries, we can ask, which source sentence supports this summary sentence? If we cannot point to evidence, the claim should be softened, removed, or flagged as inference. One useful way to think about faithfulness is a table. On the left, put each summary claim. In the middle, put the source evidence. On the right, mark supported, partially supported, or unsupported. This turns summarization from a feeling into an audit. In many systems, we combine both ideas. First, select relevant passages. Then generate a clear summary grounded in those passages. Finally, check whether the generated claims are actually supported. This hybrid pattern is common because it combines traceability with readability. This also gives you a good prompt pattern. Ask the model to summarize, but also ask it to separate source-supported claims from inferred interpretation. You might say, use only the source text. If you infer a cause or priority, label it as an inference. This does not make the system perfect, but it makes the output easier to inspect. The practical distinction is not that extractive is old and abstractive is new. The distinction is what you are optimizing. Extraction optimizes preserving original wording. Abstraction optimizes readable synthesis. The best workflow often uses both, because the summary should be readable and faithful at the same time. For practice, take one messy paragraph and create 2 summaries. First, copy only source phrases. Second, rewrite the main idea in your own words. Then ask which version is easier to read and which version is easier to audit. That comparison is the foundation for designing summarization systems. Now we can ask a more practical question. What makes a summary good? The answer depends on the summary type. You cannot judge a summary until you know what kind of summary the task needs. A very short executive summary may be excellent for a manager and terrible for a technical reader. A detailed technical summary may be excellent for a researcher and useless for someone who needs next actions. An executive summary asks, what changed? Why does it matter? And what decision should we consider? It usually needs the main conclusion, the reason, and the risk. It should not drown the reader in details. Its job is to support a decision. A technical summary asks a different question. It asks, what is the mechanism, method, evidence, and limitation? For a research paper, this might mean research question, data, model, evaluation, result, and caveat. The technical summary can be longer because precision matters. This difference matters because learners often judge summaries by tone. They say this summary sounds good, but a good-sounding summary can fail the task. If the task is technical understanding, the summary needs mechanism and evidence. If the task is executive action, the summary needs decision and risk. The same pleasant paragraph cannot optimize for both at once. An action item summary asks who should do what, by when, and based on which source. This is common for meetings and project updates. If it misses the owner or deadline, it fails, even if it sounds accurate. A comparison summary asks, how do several sources or options differ? For example, if you compare three vendor proposals, the summary should align them on the same criteria: cost, coverage, integration effort, risk, and recommendation. Without shared criteria, the comparison becomes a collection of mini-summaries rather than a decision tool. One useful way to design a summary is to imagine the output as a small data product. What are the columns? What fields are required? Which field can be missing? And which field must be checked? For an action item summary, the fields might be owner, action, deadline, dependency, and source quote. For an executive summary, they might be decision, evidence, risk, and recommended next step. So the prompt frame is simple. Define audience, length, required fields, and risk level. Audience tells the model what background knowledge to assume. Length sets the compression budget. Required fields define what must not be omitted. Risk level tells the model whether to preserve uncertainty and cite source passages. Here is a better prompt shape. Summarize this policy update for a department head. Use 5 bullets. Include what changed, who is affected, required action, deadline, and uncertainty. Do not add information that is not in the source. If a detail is missing, say missing. This is much stronger than summarize this policy. Notice that this is not prompt engineering as decoration. It is product design. You are defining the output object. A summary for a dashboard, a legal review, an executive email, and a study guide are different objects. They should be judged by different criteria. This is also where evaluation becomes much easier. Instead of asking, is the summary good? Ask field-level questions. Did it include every required field? Did it use the right length? Did it preserve caveats? Did it avoid unsupported claims? Did it fit the audience? These questions are much easier to answer than a vague quality judgment. The practical rule is, define quality before generating. If you cannot say what a good summary must contain, you cannot reliably evaluate whether the model produced one. Once you define the summary type, evaluation becomes easier. You can check required fields, source support, length, audience fit, and whether the summary preserves the right uncertainty. This is also the bridge to production systems. A summarization feature should not just have a model. It should have a summary type, a user, a field schema, and a review rule. A summary can fail in predictable ways. If we know the failure modes, we can design a safer workflow. The first failure is omission. Omission means the summary leaves out something important. This is not always a bug because every summary omits many details. The problem is when it omits a caveat, a minority opinion, an exception, or a decision that changes what the reader should do. The second failure is distortion. Distortion changes the meaning. The source says some users reported delays, and the summary says the system is unreliable. The summary may be related to the source, but it changes the strength of the claim. The third failure is fabrication. Fabrication adds information that is not in the source. It may add a date, a cause, a number, a quote, or a recommendation that was never stated. This can be hard to catch because the sentence may sound natural. The fourth failure is wrong emphasis. This is subtler. The summary may be accurate sentence by sentence, but it focuses on the wrong thing for the user's task. For a meeting, it may summarize discussion but miss decisions. For customer feedback, it may summarize sentiment but miss the product feature causing the issue. These 4 failures are useful because they turn a vague concern into a checklist. Omission asks, what important thing is missing? Distortion asks, did the strength or meaning change? Fabrication asks, was anything added? Wrong emphasis asks, does the summary focus on the part that matters for the user's decision? The safer workflow is to make summarization explicit. Step 1, define the purpose. Step 2, generate the summary with required fields. Step 3, check claims against the source. Step 4, decide how the summary will be used. For low-risk exploration, a quick summary may be enough. If you are screening 10 articles to decide which 2 to read, you can tolerate some imperfection. But if the summary drives a client email, a policy decision, a medical interpretation, or a financial action, you need stronger checks. One practical check is a claim evidence table. Ask the model or the reviewer to list each important summary claim and the source passage that supports it. Unsupported claims should be removed or marked as inference. Another check is an omission prompt. After generating the summary, ask, what important caveats or exceptions from the source are not represented in the summary? This does not guarantee perfection, but it often reveals missing context. A third check is to preserve uncertainty. If the source says may, reported, preliminary, or in a small sample, the summary should not turn that into certainty. Good summaries keep the confidence level of the source. For a practical exercise, use a short article or meeting note. Generate a summary, then run the for-failure checklist. Mark one possible omission, one possible distortion, one unsupported claim, if any, and one place where emphasis may not match the user's goal. This exercise is more useful than simply asking whether the summary is good. So the final rule is purpose, evidence, check, use. Define the purpose. Ground important claims in evidence. Check the predictable failure modes. Then decide whether the summary is safe for the intended use. If you remember one thing from this lecture, remember that summarization is not a button that makes text shorter. It is a workflow for turning too much text into a useful, faithful decision aid. The better you define the reader, the purpose, and the risk, the better your summaries become. This foundation also prepares us for the next lecture. Once we understand what a summary should do, we can talk about summarization systems, how to build them, how to evaluate them, and how to make them reliable enough for real applications.